Hello dear users of digital photogrammetric workstation PHOTOMOD. We are going on series of video tutorials for working with PHOTOMOD 6. Last time it was a question of creating digital terrain models and digital surface models based on TIM and 3D points. Today we'll consider other ways of building them. Let's start PHOTOMOD and open Project Island. As you remember from latest video tutorials, there are some kinds of dams. Digital terrain models which take into account just heights of natural relief, and digital surface models which take into account not only relief but also vegetation heights and heights of artificial objects. Apart from building dams based on TIMs and 3D points, PHOTOMOD enables to create dense DTMs with measuring heights in each pixel of an image. The first algorithm of creating dense DTM appeared in PHOTOMOD several years ago. This algorithm is based on modified local correlation method that uses CUDA technology for acceleration of calculations. In the beginning, let's define an area for modeling and draw a grid, keeping Shift key of a keyboard. Let's draw a grid in the central part of the project. Since the algorithm is developed in such way that heights are calculated in each pixel of an image, a grid step doesn't matter. The one important thing is to specify its borders. Save the grid in PHOTOMOD resources. Then let's build pre-regions. Block, build pre-regions, parameters in default. Okay. Since the similar project area can be covered by several stereo pairs simultaneously, it's important to avoid a duplication of calculations. Pre-regions enable to determine which part of which stereo pair will be used for calculating heights of output dam. To start the algorithm, let's open menu Dam, Build Dam, Dense DTM. Select All Images option for search area, specify just created vector layer. As pre-region layer, select a working folder. In default, it's subfolder DAM in a folder of the project. Leave all options of DTM computing in default. If having high efficiency graphic card, it's possible to select it as computing device. In More bookmark, let's be sure that image subsampling factor equals 3 or 4. In fact, it's a pyramid level of an image that used for searching points. Increase of its value will allow to accelerate DTM calculation. To increase a measurement's accuracy, activate subpixel correlation option. If necessary to build a digital terrain model right in this window, you can specify parameters of buildings and vegetation filter, restoring null cells, and smoothing a surface of output DTM. We don't recommend to activate delete intermediate data option. If filters parameters were specified incorrect, it will be possible to start filtration again and separately with other settings. Here input dam cell size. It shall not be less than the size of image pixel, for example a half of a meter. Start distributed processing center. Press distributed processing button, specify parameters of buildings and vegetation filters, and specify parameters and sizes of rectangular sheets. These sizes should be specified in such way that maximum task quantity will be proportional to computer's course number. I have 8 cores on my PC and 8 tasks for distributed processing. Then you should press OK, but I will not do it. I will load the DAM that was preliminarily created on the base of DTM algorithm. Then load. The result looks like this. For checking accuracies of created DTM, I can use several sources. other than tin model vector objects. But if not having them, I can check DTM accuracy against triangulation points. First of all, against GCPs. High values of height differences with several type points can be explained. They were measured on top of trees or buildings' roofs instead of natural relief level. If it's necessary to control modeling results in stereo, I can convert them to 3D points. Then convert to points. Thin-out coefficient defines in how much times a step between vectors will be increased relative to them cell size, for example 2. After opening stereo window, if necessary, I can edit position of several 3D points, create tin based on them, and create them based on tin. However, them editing is possible without preliminary converting them to points. For these purposes, there is a special toolbar, them editing. It should be noted that all operations performed from this toolbar are irreversible. Correspondingly, we should preliminarily create a copy of editing them. Then, save copy. And load this copy layer into the project. Then editing toolbar contains tools of cutting inside area, tools of setting height inside area, and tools of interpolation, smooth, polynomial, or linear. Let's close this toolbar. And then it should be noted that in PHOTOMOD 6 a new algorithm of creating digital surface models has appeared. A relief quality increases together with an increase of overlapping rate. To get the best results, it's recommended to have no less than quadruple overlapping in area where a relief is computed. Let's be sure that grid layer is loaded into the project and open menu. Then build them, dense DSM deformating method. Leave options of using all images and all cores on local PC. Check that distributed processing center has been started. Maximum number of tasks is defined automatically. If necessary, I can activate options of no filling in visible areas, for example shadows, no filling depthful areas, for example with a low correlation rate, and deleted intermediate data. While having a prepared DSM on the same territory, it's possible to load it and specify a threshold deviation from the initial approximation. Here, please specify output them cell size, for example a half of meter like in my case. Then you should press OK, but I will not do it. I will load the result that was preliminarily created on the basis of deformated method algorithm. The result looks like this. For creating dense DTM, parameters of buildings and vegetation filter were specified right in that window. For creating dense DSM, we will do it separately. Start menu, then buildings and vegetation filter, parameters in default, OK. As you see, some area of natural relief there and there has been filtered too. Let's start filter once again with other parameters. Let's change distance of point mutual influence for basic pass from 10 to 100 and for additional pass from 20 to 100. Okay. Okay, now everything is alright, but now it's necessary to fill null cells of them. Then fill null cells with smooth interpolation, parameters in default. And then, if necessary, apply smooth filter. Then smooth filter. Level option is like a height for filtering, aperture option is like interpolation window size. Okay. Thus, today we have considered two additional ways of creating dams